Good day, everyone. Welcome to our webinar on moving from Excel to artificial intelligence, creating visibility in the supply chain. My name is Mike Simon. Welcome. I'm from Define Logic. We're a digital innovation and development consultancy here in Red Bank, New Jersey, and I'll be your moderator for today. Let me first welcome our distinguished panelists, distinguished guests. We first have John Urban, who is the co-founder and president of GT Nexus. Since leaving GT Nexus in May of 2016, John's become a board member and advisor to a number of startup companies in the international supply chain and logistics space. He's also an active advisor in supply chain to major 3PLs, shippers, and private equity, and as an advisor to Clear Metal as well. Bob Zimmering, welcome. Bob is from Amazon. Bob has led improvement projects for Amazon's global fulfillment network for a number of years, building on 15 years in aerospace as a project manager, systems engineer, and Lean Six Sigma leader. And last but not least, we have Thomas Atwood. Thomas is a lead data scientist at Clear Metal, who leads their group in creating the artificial intelligence and machine learning capabilities that leverage their applications. Tom has a master's in management science and engineering from Stanford, where he also concentrated on operations research and machine learning. So panelists, again, thank you very much for joining our webinar today. And let's go ahead and get started. So if we take a look at our first slide, we see that there are a number of companies that are involved in the artificial intelligence space. Studies indicate that something on the order of $1 trillion will be spent this year in digital transformation initiatives, with a lot of that being spent on technologies that claim to leverage artificial intelligence and machine learning. So first question to John and Bob, why do you think we are suddenly seeing such a huge increase in investment in these types of technologies? John, let me go ahead and first start with you, if that's all right.
Sure. Mike, let me put it in a little bit of context of the supply chain. I mean, for years, companies who manage significant supply chains have done a lot of things in common. They've put a lot of effort into planning their supply chain, where they're going to source from, who their suppliers are, how they're going to transport their goods, and a lot of effort goes into that planning process, and then they execute the supply chain and measure its effectiveness in different stages. And as they measure, what they're looking for are sources of variability, things that cause delays or unexpected outcomes. And then they try to apply processes and technology to eliminate or to minimize that variability so that the supply chain can become more efficient. And then finally, they turn that data that they collect back into the planning cycle so they can iteratively improve their overall plan. Where machine learning and artificial intelligence really has an enormous opportunity within supply chain is in managing data far more effectively. One of the first things that the machine learning enables you to do is to collect and improve the quality of all of the data across your supply chain far more effectively than you've ever been able to do it before, i.e. you're able to do it in an automated fashion instead of hiring armies of people to do that work. The second thing that it does is today's supply chains look at data in the rearview mirror. They look at it going backwards. And artificial intelligence allows you to become predictive and to look forward and to understand what events are at risk of happening before they occur so that you can actually take action on them before they occur. So it's a big change for everybody who's managing their supply chains effectively, and it's got huge applicability.
Excellent. Excellent. Thank you, John. Bob, what are your thoughts?
Yeah, so I totally agree with John that machine learning AI methods are expanding our ability to forecast and to look forward, to clean up data. And so that's really the kind of one of the key drivers for why companies are doing it. I think that why we're seeing the increase in investment is what I would call we've got past the event horizon in terms of this technology. So if you read about machine learning, a lot of people talk about the singularity, which is this imaginary future state where machines become smart enough that they start developing more artificial intelligence and they kind of push all of humanity out of the job market. And then, they call that the singularity. The event horizon for me was crossed when we had three different things happen. The first was proliferation of the Internet of Things, or Industry, whatever, 0.0, 4.0, 5.0, that really just created a ton more available data that was interesting in terms of process management, but all that data is unmanageable, like John said, by human beings. We just can't wrap our brains around that much data in any way. So data is more available. The second is that we've seen the capability in terms of some of these companies like Google and IBM that have developed specific AI and ML approaches that can beat human beings at things like chess and Go, and recently in debating, things that we've always considered were unique to humanity and computers couldn't do. We've now proven that, in fact, they can beat the grandmasters, the world best humans at some of these things, at our own game, so to speak. And then the third is the availability of nearly infinite server space. The cloud and cloud providers like Amazon Web Services, like Microsoft and Google and others, have made the cost of servers incrementally small in terms of adding space. So there's more data to look at. We've proven that AI methods and ML methods can look at it in ways that humans cannot and beat us at our own game. And we now have available the space to capture more data than we ever could and to expand the space flexibly, almost unlimited, to house that data and to house the results. So I think those three things have made the promise of machine learning realistic, and now companies are willing to make those investments.
Fascinating. Question for you. Are you seeing any particular areas along the supply chain that are receiving more investment than other areas? John, what are your thoughts?
You know, when I look at it, the supply chain is big and broad, and I'm seeing tons of investments being made across the entire supply chain, from supplier management all the way through to settlement of financial terms. But it's really because effective supply chain management has really become a key differentiator and a determinant of the success or failure of companies in the marketplace. Supply chain performance today has become, in many cases, as important as the product or the brand itself for companies. There's so much opportunity to improve in supply chain, to reduce costs, to improve customer satisfaction, to reduce inventory investment, to achieve just-in-time systems, to manage costs and customers' experiences. To me, I think we will continue to see companies making specific investments in particular areas of the supply chain, but ultimately to get their arms around the entire supply chain from beginning to end.
Mm-hmm, mm-hmm.
Yeah.
Bob, what are your thoughts? Bob, same question to you. Are there any particular areas that are receiving more attention than others in the supply chain?
Absolutely. Sorry, I was on mute. I think
No problem.
I'll build on what John said. I can't work my own phone. So what John said is right on the money in terms of being a competitive differentiator. Most companies have already gone to reducing inventory as a way to manage cash flow and provide just in time. And what that does is makes the company and your product and your deliveries just completely susceptible and dependent on your supply chain delivering everything you need at high quality when you need it. And so what's happening is companies that have especially complex products or in the retail space are very much affected by variation, even at the third or fourth tier supplier. Because if your fourth tier supplier doesn't provide the fasteners or widgets or whatever to the third tier that builds it to your prime sub tier, you don't have your product. And it can, as simple as the analogy of, for want of a nail, a horse was lost. For want of a rivet, or I had a situation where I was working in aerospace where we were so constrained by a third tier supplier that we were counting individual aluminum tubes that would go into oil coolers that are absolutely critical for an Airbus 319, 320 to get off the ground. And so when you're working at that level of granularity, machine learning is critical to ensure that you're getting everything you need at high quality when you need it, so that you can hit your delivery schedules and deliver a product that does what it's supposed to.
Interesting. Yeah, I'm just thinking that maybe it makes sense to dive a little bit deeper into definitions of artificial intelligence and machine learning. Tom, from your perspective, data science perspective, and expertise in this area, maybe you could spend a few minutes and just give us some working definitions that might help us put all of this in context.
Yeah, absolutely. So the way I understand it and the way I've heard it explained is that AI, artificial intelligence, is kind of the broader field under which machine learning and deep learning fall. So artificial intelligence kind of falls into two main categories. There's applied and general artificial intelligence. And general AI is kind of the stuff you see in movies, where a computer has all of the characteristics of an intelligent human. And that's less of what we're talking about today, and less of what's interesting for industry applications. So usually what people are referring to when they talk about artificial intelligence is they're referring to applied AI, which is getting a computer or a machine to do one task intelligently. And machine learning is the current consensus favorite approach for achieving that kind of artificial intelligence, or artificial intelligence in general. And Arthur Samuel, the person who coined the phrase machine learning, described it specifically as the ability to learn without, for computers to learn without being explicitly programmed. And so a good example of the distinction between machine learning specifically and AI in general is maybe machine translation. The approach that most people took to trying to build computers to be able to translate from one language to another, 30, 40 years ago, it was always about building a giant library of rules, where if you see one word, it translates to this word. If you see another, it translates to this word. If one word appears in one part of a sentence, it's a noun. If it appears in another part of a sentence, it's a verb, etc. And so these are rule libraries that are hard-coded into the machine. What machine learning allows us to do is actually just take a corpus of data, and without hard programming any of these explicit rules, we allow the machine, we provide the framework for the computer to kind of learn all of the patterns and correlations itself. And so today, what people will do for training natural language processing algorithms is they'll take the entire New York Times database from 1980 until present, and they'll literally just throw that into an algorithm, and the algorithm will figure out all of the patterns and things like that without the programmer having to explicit any language-based rules themselves.
Interesting.
Yep.
So with the mountain of data that we're talking about and the deluge coming from things that you mentioned, Bob, around IoT, for example, how is it that industry's handling all this data today, particularly if organizations don't have the kinds of tools that we're talking about? John, what are your thoughts there?
I think in the last 20 years, we've come a long way from supply chain systems that were based solely on user interfaces and EDI connections to carriers and the like. And we've seen introductions of all sorts of elements of IoT from RFID to cameras and video to intelligent sensors. And it really does create a multitude of opportunities for companies to invest in to improve the function of their supply chain. I think the two things that people really need to think about when they start engaging in sophisticated IoT strategies is developing a strategy or a plan that identifies which events you're really going to need and want to collect, and frankly, to ask the question of what are you going to do with the data when you get it, because just managing this huge amount of data and then not taking action on it is certainly a waste. But you need to recognize that the IoT events that are coming in are not the supply chain system itself. They're simply what they promise to be. Is they're events that add richness and insight into your overall supply chain management system. I think the second thing people really need to focus on is a recognition that they really need when they're going to add this much data to their supply chain, they really need a strategic plan for how to manage that data. And what I'm really talking about there is that in many cases, this IoT data really needs to be curated. It needs to be understood in the context of other data that's on the platform and in the context of what it means. And from a machine learning perspective, what that means is that in many cases, you really need to add the human element back in to provide the rules and the context that allow machine learning to spin up and do a better job than it would on its own as this data begins to come in. So a curation plan to make sure that the data that you collect is effective and utilized to its best advantage is really, really critical.
Bob, same question to you.
Yeah, I think along with making sure you've got a plan, that's definitely critical. But I think what I see as lacking is the understanding of what's the most critical to set up a machine learning program, which is first and foremost knowing that you've got a consistent, reliable, robust set of data streams that are going to help you understand what you want to drive and deliver, not just a bunch of interesting stuff. Secondly, a way to clean that data, because invariably data is going to be dirty, and dirty data actually makes machine learning. There are some approaches like scarcity that make it better, but most of the learning algorithms, if you've got bad data or you've got dirty data, it makes it much, much, much harder. And then lastly is really setting up the rules. And I think without exception, the groups that I've seen starting new ML projects just kind of jump in and they just try to start developing algorithms. They hire a couple of experts and they say, here's a big pile of data. Tell us what it means, and that's universally been kind of a misguided approach, because you don't, without a good set of rules, you're creating a much, much, much too complicated problem definition. And typically ML people are happy to dive into data and do that all day long because it's interesting and it's fun. And what you really need are people like business analysts, business intelligence folks to work hand in hand with them. So that's always my recommendation, is get some folks that really are used to looking at analysis, don't necessarily have the ML skill set, and then partner them with folks that can do the heavy number crunching and algorithm development to build the tools that they need. And then, like I said, figure out where your data is going to come from, make sure it's robust.
Mm-hmm, mm-hmm. So Tom, that's interesting. Both John and Bob are talking about, sort of a structured approach to strategic intent. To John's point, what are you going to do with the data? A curation approach, having a rubric around data quality, around rules, creation, and things of that nature. From a ClearMetal standpoint, how are you embracing that kind of a rubric? How are you embracing supply chain in particular with your tools? And tell us a little bit about how you're accomplishing what you're doing.
Yeah, absolutely. So first of all, I completely agree with everything that's been said. There are kind of different regimes that you work in machine learning, and we're getting to a point with certain applications where there is so much data that you don't need to have as much explicit understanding of the domain. And I think machine translation is one of those things. Image recognition is another one of those things. But when we're talking about supply chain data, we're still in the regime of data quality and data volume, where it's really important to have some sort of industry expertise and understanding of how the underlying supply chain works to make sense of the data and to structure it in a way that you can actually program these algorithms and make use of this data with computers. So for us, we've spent an enormous amount of time working on specifically that problem, which is how do you canonicalize data that's coming in from a bunch of disparate sources that's dirty. Most of this data is events-based, and we get events that are out of order. There are events that are missing. We receive data from different carriers, from 3PLs, from freight forwarders, from a bunch of different parties. So there's no universal standard for any of these events that are transmitted to us. So a big part of our job has been structuring that data in a universal format and finding ways to extract consistent patterns across those data sets, even though the data is coming from different places. And what we've done is build actually kind of a hybrid machine learning system that actually is in place just to parse and clean and structure that data.
Mm-hmm. It's interesting. You've all touched on the human element, both in terms of using artificial intelligence, machine learning to eliminate the tasks that humans can't possibly do, but then also leveraging those capabilities to enhance the things that maybe only today, at least, humans can do. So if you could touch a little bit more about the human element of individuals in a machine learning, artificial intelligence environment. John, what are your thoughts there?
I think, well, what comes to mind when you ask that question is there's certainly a fair amount of fear or concern out there that machine learning, artificial intelligence are going to be challenging to jobs and be negative on job creation, maybe even eliminate jobs. And I think, given its, when you project out to its full natural extension of artificial intelligence, that could in fact be a concern. But when I look at least for the next 10 years or beyond, I really see the kind of classic technological dilemma coming up where machine learning will automate things that are rote and boring and eliminate human effort from that sort of work. Improving the quality of data would be an example of something that machine learning does far faster and more effectively than people can do. And in that regard, it frees people up for higher level functionality, for more creativity, for more insight, for more planning. That said, it does create change and does create pain with change, because people need to get retrained and be prepared for the new skills that are going to be required in the world as technology continues to advance. So I think Tom talked a little bit about the kind of supply chain knowledge and data that needs to, or knowledge that needs to go into a machine learning strategy. And I think those are the kinds of jobs that will be created as we move forward with all of this investment.
Interesting. Bob, what are your thoughts?
Yeah, the running joke is that when artificial intelligence replaces humans, and humans will just be doing jobs that don't require intelligence. That's obviously not true. So the hard part is the training, is the transition, is that there's going to be a lot more jobs developing algorithms to do analysis rather than doing the analysis. And that's actually a really good thing, because there's a lot of our workforce that are currently tied up with endlessly scrolling through Excel spreadsheets and looking for that magic number on, cell XX137 and then typing it into some other SAP thing or something. So it's actually a good thing in terms of the type of work that we're replacing. And we've seen that with automation as well, taking the hottest, dirtiest, most dangerous jobs and giving them the machines. So the hard part will be transition and people learning those new skills. But really what it does, or what I hope it will do, I anticipate, is that it'll get rid of those mind-numbing repetitive jobs and open up people to do the kind of stuff that is actually more interesting, that is enabled by machine learning. So if we have more accurate supply chain forecasts, if we have more reliable data on process variation, if we have more tight controls, we can get away from firefighting, because we've got more consistent process, we've got more consistent product delivery, and we can get away from firefighting and instead put people on strategic tasks where they can be thinking ahead, looking across boundaries, and building bigger platforms to work on. So that's where I believe the opportunity will open up. It's just a matter of whether the workforce can transition to it and what are the constraints we have. For example, in the United States, we have a tremendous talent challenge right now for skilled talent, and it's really going to get worse for a while and open up internationally. So it'll be challenging, no doubt about it.
Okay. So let's talk about some of those strategic tasks and strategic questions that supply chain executives are looking to these types of tools to help them answer. Looking here at a recent study from CSCMP and different types of questions that supply chain executives are looking to have answered, and what resonated with each of them relative to how far along the transformation journey these types of tools are. So, for example, being able to utilize these tools to indicate what happened, why did it happen, will it happen again, and now what should I do, getting into sort of the more predictive realm. If we take a look at the numbers here of respondents in terms of what resonated with them. John, did these numbers surprise you at all?
No, they really don't, but they're actually pretty insightful. I mean, if you obviously it's a view from the far left where things are very focused on what's happening now to a more predictive supply chain on the far right. And the top line indication is, geez, people are much better at looking at what's happening today. And they really haven't yet gotten around to trying to drive into predictive supply chain and figure out what's to get out in front of the ball and get outside the rearview mirror. So that to me is clear, and that's what so much investment is going into BI and machine learning at this point. But the other thing that comes out of this is just the what happened bar of 62%. The fact of the matter is that 38% of the world doesn't even feel like they're doing that well today. So I think it really underscores the fact that there's so much to do yet in supply chain, and we are in this world where companies need to fine-tune those skills so that they can become competitive and survive, and yet 38% of companies don't even feel they do a good job of understanding what's happening today. So a lot of work to be done is my biggest takeaway from this slide.
Okay, Bob, what are your thoughts?
Yeah, so CSCMP is a great organization. They've got a pretty straightforward maturity model that applies to AI and ML that tracks the level of autonomy and differentiation as a result of those enablers. I would look into APIX, which many folks in supply chain world are also familiar with. They have a really robust maturity model that is called SCORE. I forget what it stands for, but you can look that up. There's a lot of information on it, and they've recently updated to a really comprehensive new version of that maturity model. They did it in 2017, and it includes process, performance, practice, and people, and it's specifically expanded to include big data, multi-channel, and automation kinds of things. So in terms of tracking transformation, I think it's instructive for anyone who's leading a supply chain department or leading a technical group working in this area to really look into those maturity models and just understand what are the complexities and what are the different axes of technology that need to be built out. In terms of how far along we are, I'm a little remiss based on how much investment has been in this space, because it is still, like I mentioned, it is still very reactionary. It's very much firefighting. What happened? We already know what happened. The thing didn't show up on time, or the thing showed up and it was, the box was missing 3 units, or the quality didn't meet the most recent specifications because the drawings hadn't been updated or whatever. We already know what happened. I don't think it's really helping us to have better information on what did happen. I think understanding root cause, why did it happen, will be really interesting. It's not that far along. I think it's actually a very particular challenge, because you get root cause analysis is something that's very, very hard to teach computers to do. But what will happen and what can I do, which then I can use to determine what should I do, those bars, those areas are very ripe for machine learning. And again, I'm a little disappointed that for all the investment we've made, we're not getting really much more bang for our buck in terms of predictive models. Forecasting is still the hardest and most frustrating part of supply chain management. All of our S&OP processes are fudged, and all of our rough cut. Our CCP process is always rough cut. The word R still means rough. When do we get to fine cut? And that's where I want ML to take us, is to really improve forecasting by an order of magnitude, and then give us the insight and the actionable intelligence to decide what to do about things, and stop worrying about that bar to the left about what happened in the past.
So I'll come
Mike,
to a question
I'd just
in a
like
moment.
to add, I think.
Yes, go ahead, Tom.
Sorry,
Where does clear metal fit along this continuum, Tom?
Well, just to jump in quickly before even answering that question, I think part of the reason we're seeing so little traction in these latter two categories is because of how poor an understanding we have of what happened still. Looking at the data that we have historically, it's sometimes even for a human looking at the statuses that we get for individual containers, it's hard to figure out in some cases what actually happened because there are so many events that are missing, events come in out of order. The quality of the data is so poor in some cases that you really struggle to piece together the container's journey from what you can see. And when you think about the fact that what happened is really the backbone for training models in order to predict what will happen, it's not surprising that with only 62% confidence in what happened, you're only going to have 31% confidence in what will happen. And I think that's part of the reason that at Clear Metal we've spent a lot of time trying to figure out what happened, and that's been the bulk of the time that we've invested in, or at least the time we invested in the first couple of years of this company has been spent working on what happened. And I think we've finally nailed that to such a degree that we're able to answer the question, what will happen? And once people have confidence in that, then you can start thinking about, automation. What should I do? How do I optimize these processes and things like that?
That's very helpful. John and Bob, do you want to dive a little bit deeper into why it is that transformation is so hard? Tom talked about the quality of the data relative to what happened as being one challenge. If you could dive a little bit deeper into other areas where relative to what makes transformation so difficult.
Sure. I've seen a lot of transformation efforts and worked with a number of companies in the midst of transformation. And two major issues really kind of come up to bite or to make the transformation difficult. The first one I want to talk about is really getting far better visibility into your supply chain is incredibly helpful. But the fact of the matter is there's a tremendous amount of work process built in every organization today about how they address things. So when you change the system dramatically and you move to a new technology that gives you far better insight, if you don't change everybody else's job, if you don't cut them off of the existing systems that they're working on and allow them to transition over to the new system, it's not gonna have an effect. And managing that transition, that plan for work processes and people skills to change to embrace the new technology is certainly as large and probably a much larger task than the new technology itself. So change management is the number one reason I think that people really do struggle, and they wonder why it takes them longer to get results. The second thing I think that companies and people struggle with is the fact that it's kind of the biblical nature, if you will, of technology. And I'm thinking there in terms of the first will be last and the last will be first. And companies that 10 years ago made significantly large investments in their supply chains are finding that technology has outpaced them and changed. And if they didn't have a great plan in place to keep up, they're now suddenly behind. And now the flip side of that is that companies that as of today haven't done much have a green field in front of them and an opportunity to invest in technology and more easily and effectively in many cases. But I think the things that a lot of people struggle with is how do you, once you make a technological investment, how do you make sure you refresh it in effective ways that allow it to keep pace with the very technology change that's happening in the environment today.
Bob, what's your experience been relative to why transformation is so hard?
Yeah, it's a huge change management issue, and I worked in continuous improvement, Lean Six Sigma kind of stuff for a while in my career, and it's amazing how tough it is to get folks to change. And I think the thing we've got to look at, John mentioned all the barriers to change, which are absolutely correct. you know, all the technical issues. We've talked about them, particularly data. Absolutely correct. But at the end of the day, people have to want to change, and the incentives to change have to be, in general, have to be more compelling, much more compelling than the current state. And so what we need to get to is really a compelling case or drive for folks in leadership to make the change, and then to really communicate that down all the way down to the folks that are doing analysis. I'll give you an example. We had a pretty big ERP rollout at one of the companies I was working with in Germany. And they were using a European tool. It wasn't SAP, but it was a European tool, and went through the whole 9 yards, did customer requirements, rolled out their system. You know, it was promised, of course, to be better than sliced bread. And you know, everyone in leadership had high hopes, and then we rolled it out, went through the user testing, everything was great. And then I went to sit with the folks who were doing their planning, and you know, how are they doing ERP? Well, they're going into the new system, they're getting a screenshot of the orders and promise dates and all that kind of stuff. They're getting a screenshot, and then they're manually typing that stuff in Excel. They're moving stuff around in Excel to try and figure things out. Then they're going back into the system to update the data with what the analysis they did in Excel. Why would they do that? Why would they do that after this huge investment in a system that leadership is convinced will make everyone's jobs easier? And that's the key question to any change management, and particularly with machine learning, because people are so conditioned to just brute force approaches that they're used to and get the job done. We have to make it a situation where they cannot get the job done using the existing methods, using Excel, using brute force, using the standard statistical packages, and that the only way that the folks doing the work can get their jobs done is by adopting at least the output, the results of machine learning, not necessarily programming the output, but they have to feel that the only way they can get their job done is this new thing. And that's a huge hill to climb right now, particularly because it hasn't shown, it hasn't lived up to the hype, it hasn't lived up to the promise. And so folks are honestly just seeing it as one more thing to keep track of.
Yeah. So the slide that we're looking at suggests that there's a large percentage of companies, 80% of companies, in the search that we did, that will invest in artificial intelligence in the next 1 to 2 year time frame. Tom, what guidance would you share with companies like these that are looking to answer the question of what should I do with the challenges that Bob and John have spoken about?
I think there are two first steps. First, I would say it's all about the data. So it's really important that they take inventory of the data they already have and develop some sort of strategy to collect data that they think is valuable to the decisions they're trying to make in the future. And if they're not currently collecting data, it's really important that they start. So I think that's kind of one of the first steps. I also think it's really important to pick kind of a narrow use case that is directly driven by some sort of value for the company. A lot of the time, people, I think, come to machine learning with this idea like, hey, here's the data that I have, what can you get out of it? And it doesn't really work that well when you come at the problem that way, because it's not focused. You don't have a clear task at hand that you want to achieve. It's much better if you're trying to figure out, hey, this is the problem I have. And then maybe you figure out, hey, what data do I need in order to make those decisions, in order to train models to learn across that spectrum, et cetera. So I think it's really important to define a very narrow use case as a starting point. Maybe I can give an example, actually. So one example would be like, instead of just saying, hey, I've been collecting all of this supply chain data, what can you do with it? If you're trying to answer the question, should you ship by ocean or should you ship by air because you're dealing with a tight deadline, then you start, collecting data on the risk associated with both. So you'd want to know, like, how often will I be delayed if I'm shipping by ocean? How often will I be delayed if I'm shipping by air? You'd also probably want to start collecting data on the cost associated with both, because in order to make a decision, you want to weigh the risk of delays and the risk of not having available inventory with the cost of choosing one or the other. So that would be an example of a very narrow problem that you're trying to solve. Whereas the tendency, I think, in general, is to just look at all of the data across the supply chain and just see, hey, what works.
Interesting. John, I've heard you share the phrase that supply chain is the future battlefield of corporate survival. You touched earlier on supply chain being important, in fact, to brand and to brand promise. With it being that critical, where would you start in a supply chain transformation?
Yeah, it is obviously enormously critical, and I think to me, always a good place to start is with your transportation and logistics providers in any big, robust supply chain. They do several things. One is they create the most data. They cover your supply chain for the critical out of control periods. Their data, unfortunately, has historically been the worst provided in many cases by supply chain partners. So to take advantage of machine learning and bring that large amount of data in through connections with those parties in the logistics portion of your supply chain, I think is a really smart place to start. And then as you begin to see control and begin to make better and better logistics and transportation decisions, to then figure out how to back up further into your supplier network and maybe even forward into your last mile aspects would make some sense. But starting with transportation logistics providers, I believe has time and again proven to be the best early returns that companies can take advantage of.
Mm-hmm. Tom, what are your thoughts on the same question? Where would you start?
Could you just repeat the question?
So the question would be, given all of the potential for and the criticality of supply chain transformation, what guidance would you provide in terms of where to start?
I think, just to reiterate, I would definitely say take inventory of your data and then really pick a narrow use case. I think that's where most people end up failing, is that it's a bit of a chicken and egg thing. They just have a whole set of data and then they try to go after a bunch of different things, and it's not a well-defined problem. So I really think that helps, and I really do think it's important to start keeping track of how clean your data is, what data you're collecting, structuring it in a way that's usable for machine learning, with an emphasis on making sure you have historical data to train these models and things like that.
Panelists, I just want to say thank you. This has been fascinating. We're at the end of our list of topics. We're going to send out survey questions to those that have joined us today and who are listening in, and we'd really love to have your feedback. So if you would be on the lookout for an email with a link to the survey questions and also a link to this webinar recording as well. And we'd love to hear back from you. So again, for those that joined, thank you very much. And that concludes our webinar today. Thank you, panelists.
Thank you.
Thanks, Mike.